Okay, so I just give you guys a chance to think about it on your own by giving you guys these charts. What is a function? You just read the complicated definition out of the book. And that's true, but not everybody understands it at the first glance. When I think about what a function is, I think of this. When every domain, I think I spelled domain wrong.
You don't need to eat.
Yeah, I don't need to eat. When every domain element, I have to say element because you don't always have numbers in functions. And every domain element is mapped to exactly one range. I know I'm not supposed to capitalize those, but they're important. One range element. You can say the same thing, like instead of saying elements, you can say number. Okay? So if every thing in the domain is mapped to exactly one thing in the range, then it is a function. Check it out. We could not use numbers for a second. Let's not use numbers. Let's talk about this school. There's counselors and there's students, right? Now, if I have, so my domain, we're going to say is counselors. Hopefully I spelled this right. The counselors, let's say counselors, we have counselors A, B, and C. And then the range, we're going to say are students. I'll say stu for short. So we got stews and counselors. Now, is it a function? Let's see, 1, 2, 3, 4, 5, 6. We'll say we have 6 students. Now, we know there's more than 6 students. We know there's more than 3 counselors. But would it be a function if I said from counselors to students? Like if domain was counselors and it went to students, is that a function?
No.
How do you know that's not a function? So this one right here, the green one, this one's not a function because for each counselor, a counselor can have multiple students. See, this one is mapped to 3 different elements in the range. It's 3 different students, and so that one is not a function. But if we switch it, if we make students into the domain, each student is mapped to 1 counselor. Does it matter that the range has more domain numbers connected to each of the elements? No, that doesn't matter. That's not what defines a function. A function says for each domain element there is a unique answer, or not unique, I shouldn't say that, but there is 1 element in the range that it is mapped to. You can think about it like this. Domains are not allowed to go and cheat. They can't cheat. They have to have only 1. But ranges, they're allowed to cheat. All right, so let's look at some algebra for this. Okay. Now, how do we write in function notation? Now, this is weird. You guys are going to be like, what? And some of you guys will be tripping out. And some of you guys will just accept it because you're really good at learning new languages. That's what this is like. Let's talk about this one right here. So you guys are like, no, I'm not good at learning new languages. Okay, but hang with me. I'm going to write a function of x for this one. Now, that's what you guys know. You guys know how to write a function of x. It's quite simple, actually. You get the y alone. You have to just get the y alone. So solve for y. We move the 3x to the other side, so we have negative 3x plus 10 equals negative 5y. Then we divide everything by negative 5, so we get y equals positive 3 over 5x minus 2. This is a function of x because the y is all alone and the x is getting stuff done to it on the other side. We could technically write this a different way in function notation. We're going to name it the f function. And we would put an x inside this f function because it's a function of x. And on the other side, we just have 3 over 5x minus 2. See, we could just take out the y and put in our function name, which is f, and then plug in, or make sure you have right there like what it is a function of. So in short, this is the function name, and that is what you're plugging in. So this is a function of x. You're plugging in x's. Okay? It's a function of x. Okay, can we make this into a function of y? Absolutely. We do it the same way. We just have to get the x alone. So we're going to take that 3x minus 5y equals 10, and we're going to move the 5y to the other side. So we have 5y plus 10 equals 3x. And then we divide everything by 3 so we can get the x alone. So we're going to have x equals 5 divided by 3y plus 10 divided by 3. Doesn't look as pretty, but this can also be a function. Now, because we're in the same example here, I'm going to name it something different. We're going to name it the g function. This is a g function of y because we're plugging y's into it. And so we have 5 over 3y plus 10 over 3. Boom. That is a function of y. Now, they are functions. These ones are functions, and you can think about the definition of what a function is and double check it. If you plug in a number into this right here, will you get only one result? Well, yeah, right? You will not get two results. Like if I plug in a 0 right here, it'd be 0 times 3 over 5, then I'd subtract 2, I get negative 2. There's only one result. There's no way to get a different one, right? So this one is a function. What about this one down here? Is this a function? If I plug a number into y, will I only get one result from it? Let's see. If I plug a 1 in there, that would be 5 over 3 plus 10 over 3. That would be 15 over 3, which is 5. Isn't that one result? It is, isn't it? Ah, it's a function of y. Yes, if it's a function of y, it is a function. Now, some of you guys are tripping out. You're going, what? Y is always range. Why are you doing this? No, you can change it. It doesn't matter. Y is just a representation of something that's the result of a function. Okay? The results of functions. I mean, they shouldn't have taught you x and y from the beginning with. They should have taught you this. They should have said, this is the domain and this is the range. No x and y's anymore. Domain and range. Okay, but yes, we are still going to have x and y's in here, so don't think that they're going away. Somebody goes, no, I love x and y. Don't worry, it's not going away. All right, but what about this one? This one's a little different. Why? Because of that squared right there. So let's make this one into a function of x. In order to make this one a function of x, we have to get the y alone, so let's do that. We move the negative 3x squared to the other side, and then we have negative 5y. We divide everything by negative 5, we get y equals 3 over 5x squared minus 2. So it's almost the same thing as this guy over here, but there's a squared. So I can name it. Let's see, we use g. Let's use h, the h function. So there's a function of x equals 3 over 5x squared minus 2.
I have a question.
My question, I have a question too. Here, let me pause it here. Now my question is this a function? Will this give you one range number if you plug in one domain number?
No.
Yeah, it's a squared, so that does something different. Ooh, let's think about that. Okay, actually, let's think about that in a second. Let's make a function of y out of this. Okay, let's do that. Let's see. We gotta move the y over, right? So we have 3x squared equals 5y plus 10, and then we have to divide everything by 3. So we get x squared equals 5 over 3y plus 10 over 3, and then what do we have to do to get that x alone? Square root. And whenever you square root inside of a equals equation, it's plus or minus 5 over 3y plus 10. Now some of you guys, your wheels are turning. You're like, oh, I think I know where he's going with this. All right, so let's name this one. See, I use the h. Let's use j. J.
Why not
I don't want to. J of y equals plus or minus, because I represents imaginary numbers. We just don't want to go there. Okay, 5 over 3y plus 10 over 3. All right, is this a function? I'll give you a hint. This one or this one is not a function. Which one is not a function? Which one will give you two results if you plug in a number?
The bottom.
Yeah, the bottom one. You see why? And you guys know why? Because of the plus or minus. Because there's a plus or minus there, that means you're going to get two answers for whatever you plug in. Let's try 0. Plug 0 into that y. 0 times 5 over 3 is 0. Yay. And now I just add 10 to it. And 10 over 3. And so I have the square root of 10 over 3. But not just one positive square root of 10 over 3. You have to do the negative square root of 10 over 3. So there's two answers for one domain number. Therefore, this one is not a function. And this is just so you guys know, once it's a function of x, x is your domain. Because this is a function of y, actually it's not a function. Because this is a function of y is your domain. Because that's what you're plugging in. Whatever you're plugging in, that becomes your domain. Okay? Does that make sense? And I want to take a look at one more thing. Let's see.
So the domain changes?
Yeah, you can change the domain. It doesn't always have to be x. My life is over. What are you telling me? Everything's a lie. Alright, it's recording. So, this is what we had before. Just because you guys are used to looking at tables, if I were to make a table for this one right here, the one that's not a function, it would be A goes to 1, A goes to 2, A goes to 3, right? There's the 1, there's the 2, there's the 3, right? You see how the A is getting repeated? This is my domain, this is my range. If I was over here with my domain and my range, the A, oh, that's not a domain. The 1 would go to the A, and the 2 would go to the A. See the 2 goes to the A. And then let's see, 3 goes to B. And see, no domain numbers are repeating, right? They only have, each of these domain numbers have one line coming off of it, which is what a function is.
But how do we know which one is the domain?
Okay, so let's take for example this formula that you guys know. You guys know this formula: distance times equals rate times time. Let's simplify it. Let's say d equals RT. This has three variables in it: a d, an r, and a t, which we can't have for just a regular domain and range graph. So we need to have one of these. Let's put a rate in there. So let's say the rate is, I don't know, give me a rate. Give me a rate. 2. All right, we're going 2 miles an hour, and there's your time. All right, is this a function?
Yeah.
Is it a function of t, or is it a function of d? It is a function of t. So you can actually, name it, whatever, f of t equals 2t. Can you make this into a function of d if you wanted to? How would you do that? Divide by 2. You wouldn't subtract 2t because then that would put the t on the other side, but you don't want that. You would just have to go divided by 2, divided by 2. So you have d divided by 2 equals t. Now it's a function of d. Does that make sense? So you can write it like this: g of d equals d over 2.